Alright, so we've seen this before with the 6 roses and the 2 sunflowers. And we'll use this information to help us complete the table. And then we'll plot the pairs of values on a coordinate plane. So just real quick as a review on these. The coordinate plane, and this one specifically, has these 2 lines like this with the grid. This is what we call the y-axis, and you guys should know this already, which corresponds with y values in what would be considered an ordered pair. So these are my y values. And then we also have the x-axis right here, which corresponds with the x values in what would be an ordered pair. So x values here first. So if we ever forget about this, just always know that it's always going to be in alphabetical order. It goes x and then y, and we're only dealing with those 2. Of course, sometimes we extend these lines, and we may have something that looks like these. Okay? So we have x values and y values. For example, if I had the point 2, 1, then my x value is 2, so I would find that on the x-axis. And my y value is 1, then I'd find that on the y-axis. And I would find where the 2 points meet. And whenever I put a point on a graph, I should label it as well. So on this one, we could even start with this table, and we've already seen that each of these should be ordered pairs, which means these are my x values, and then these are my y values. So that means I could plot that point right off the bat. X is 0, y is 0 right there, so we can label that 0, 0. But they also gave us this point right here, 2 sunflowers, so I see x is sunflowers, 2 sunflowers, and 6 roses. Y is the roses, so 6 and 2, 2 and 6 rather, would be this point, 2, 6. But we should figure out these other ones. So this is a ratio of 2 sunflowers to 6 roses. And yes, we already did this stuff, but it should be good to look back and just do one of these at least. Let's look at this for 1 sunflower, which is this value right here. And we'll figure out how many rows. So we divide that by 2 to get the 1. 6 divided by 2 would be 3 roses. So I got 1 3 right here. 1 sunflower, 3 rows, bam. And then I label it. Alright, so this next one, we got 3 sunflowers, so we should have 9 roses. So I find 3 sunflowers, 9 roses, bam, that's this point. And then I label it, 3 9er. And then I've got 4 and 12, so 4 sunflowers, 12 roses. That's actually about all we can fit on this graph anyways. But we can still figure this out. If I had 15 roses, I should have 5 sunflowers. Alright, so what does the point 412 represent in this situation? Well, 4 was the x values, which is sunflowers. So that would be 4 sunflowers. And the 12 was the y value, which was roses. 4 sunflowers and 12 roses. See, write the ordered pair that represents 9 roses and 3 sunflowers. We already have that up there, but sunflowers was the x value and the roses y value, so 3 9, which was this point right here. Which point represents a total of 8 flowers. Well, sunflowers and roses are both flowers, so we need 8 total flowers. Looks like that would be 2 sunflowers and 6 roses, so that's 2 6. If I have 100 sunflowers, how many roses should I have to keep the same ratio?
300?
So yeah, 300, right? Because we know 1 sunflower would be 3 rows. So if we had 100 sunflowers, we should expect 300 roses. Because we'd multiply by 3 on both of these. Shelley made a bouquet with 8 roses and 4 sunflowers. Is this the same ratio? No, it is not. If she had 8 roses, then she would have some kind of fraction of sunflowers. If she had 4 sunflowers, she would need 12 roses, which is shown in the table. So the answer to that one is no, because the ratios are not equal. So this one's just kind of the flip version of number 1. So for example, and it told us this already, and this was from example from 3.5.1, is if you got 2 sunflowers, then you'd have something like 6 roses. So if I had 1 sunflower, I'd have 3 roses. And again, this would be just the flip table from the last problem. If you have 0 sunflowers, you should probably have 0 roses. And we can work our way down on these. So that would be 9, 12, and then 15 roses. So now that we have these are all ordered pairs. So for example, this is an ordered pair. So I find where x is 0 and y is 0, which gives me this point. Now every point that we put on the graph, we have to label with its ordered pair. 0, 0. So let's get those other points on the graph as well. But now we got to label each one of these. So we have all these points, and now they're labeled as well. Now remember, we got to look at these. For example, it asks, what does the point 12, 4 represent on this? That would represent this point right account. Now the 12 is x, which is roses, so that's 12 roses. And the 4 is the y, which is sunflowers, so 4 sunflowers. So the next question is, which point represents a total of 20 flowers? So that would be this last one right account. It's not on the graph, but it would be the 15 roses and 5 sunflowers gives us 20 total flowers. So 15, 5 would. If I have 45 roses, how many sunflowers should I have to keep this? Just keep the same ratio. And we'll write the answer as an ordered pair as well. So up in here, we know that we got 3 roses for 1 sunflower. And we want to keep the ratio equivalent for 45 rows. And how many sunflowers? Well, we know we can multiply the 3 by 15. So multiply that by 15 equals 45. The 1 times 15 then would give us 15 sunflowers. But it asks us to write this as an ordered pair. So the x is the number of roses, which was 45. And the y is the sunflowers, which we found to be 15. 45, 15. A recipe calls for 1/2 cup lemon juice for each cup of water. Complete the table and plot the points of values on the coordinate plane. Okay. So if we use 0 cups of water, that wouldn't require any lemon juice. Alright, now it did say at the top there, 1/2 cup of lemon juice for each 1 cup of water, so we should have 1/2 cup right there. So, and this is how this would work, right? We could set up the proportion. So I have 1 cup of water, which would give us 1/2 cup of lemon juice. But now we're looking at 2 cups of water. So how many cups of lemon juice? Well, we would multiply that both by 2 and get 1 lemon juice. So you could set up those fractions the same even if the table's not in order, and you should be able to find those values. So 3 as well. So now I'm going to multiply this by 3 to get 3 cups of water, and that would be 3 halves. No mixed numbers. We want to show this is 3 halves right here, because we would need, we're looking for 3 cups of water, right?
Did you have 1.5?
Yeah, that'd be fine. So I'd have to multiply the 1 by 3 and the 1/2 by 3 as well to get, well, that would be 3 halves right there. That's better. Alright, so what about 4? Well, we can look at the 2 cups of water for 1 cup of lemon juice and double that as well. So yeah, that would be 2 cups of lemon juice. So if I wanted 15 cups of lemon juice, let's go ahead and look at that one. But I'm going to continue to use the unit rate on this. So I want 15 cups of lemon juice. That goes in the denominator right here. So I would have to multiply that by 30 right here. And I would multiply the water by 30 as well to get 30. 30 cups of water for 15 cups of lemon juice. Now some of you guys saw that the water is just double whatever the lemon juice is. So 1 times 2 is 2. 3 halves times 2 is 3. 2 times 2 is 4. Something like that, okay? So you may have seen that, well, 15 times 2 would have given us the 30 as well. That's okay. So we should be able to graph these now. So I have this point at 0, 0. I got 1 and 1/2. Then we got this 2, 1. And 3 and 3/2. And 4, 2. And then finally, well, I guess we can't fit this one, 30 and 15, but hopefully we see that there's a pattern on this. That's just taking this up 1 and 1 each time. And we could connect these points if we wanted to, like this. So what does the point 4, 2 represent? Yeah, and we can see that in the table, right? 4 cups of water and 2 cups of lemon juice. But what if I use 100 cups of water? How many cups of lemon juice would I need to keep the ratio the same? 50, yep. I would need 50 cups. How do we get that? Well, the cups of lemon juice is just half of whatever the cups of water is. Yeah, so this would be an ordered pair, right? So in other words, it said 100 cups of water, and this is what it would look like in the table, right? If we extended this. And then we got 50 cups. So the ordered pair would be 100, and then 50. If I have used 60 cups of liquid, how many cups of each would there be? So for 60 of these cups, we don't have anything that shows it. I mean, this one's pretty close with 45 cups of total liquid. So we can look at this as a ratio either as of cups of water or cups of lemon juice. I would say cups of water. Alright, so I would use this unit rate though. 2 cups of water for 1 cup of lemon juice. So 2 cups of water of H2O for 3 cups of liquid. But what we want is 100 cups of liquid. So what would that be in H2O?
This is liquid though.
Yeah. Yeah, overall. So, yeah, so 2 cups of H2O and then 1 cup of lemon juice would give you 3 cups of liquid. So to do this one, we'd have to multiply this by 33.3 repeating. Or you could just multiply it by 100 thirds. Either way. So I would multiply the 2 by 100 thirds. And I would get 200 thirds cups of H2O. So 200 thirds cups of water. And to figure out the lemon juice, I would just cut that in half. So divide that by 2, and we would get 100 thirds cups of lemon juice. Hamid mixed 2 cups of lemon juice and 3 cups of water. Did he follow the recipe? No, because 3 cups of water should have been 3/2 cups of lemon juice. So yeah, he definitely did not follow the recipe, but that's okay. What is the unit rate? Cups of lemon juice to cups of water. Where do you see the unit rate on the table? There were 2 unit rates we found.
1, 2.
Yeah, 1 cup of water H2O to 1/2 of lemon. But there was the other one that we had already used, which was 2 cups of water to 1 cup of lemon. And that would be the second unit rate. So in a proportional relationship, the unit rate shows the amount of y that corresponds to 1 unit of x. We can also think of this as the amount of x of increase in y as x increases by 1 unit. On a graph, the unit rate is illustrated in the point 1r, where r is the unit rate. So if we looked at a graph like these, then we would look for x is 1, and then whatever the y value is the unit rate. So they're saying that that is some value r, so you'd have the 1.1r. The unit rate can also be determined by finding the quotient y divided by x. In a proportional relationship, y divided by x is constant, which is why we call it the constant of proportionality, or the proportional constant. All it's saying is that all the ratios have to be equivalent. And whatever you divide the y divided by the x by will be your proportional constant, or your unit rate. John is riding his bike at a speed of 12 miles per hour. Complete the table and graph to show this relationship. So if he bikes for 0 hours, we should expect him to go 0 miles. If he bikes for 1 hour, because that's miles per 1 hour, we should expect him to go 12 miles. If he goes for 2 hours, so 1 more hour would add 12 to that to get 24. Alright, so here are the values that we have in the table. And we could have found these by multiplying the number of hours by 12, because it's 12 miles every hour. And now we can put the points on the graph. So the points we see should be, we got a point right here, 112, 224, 336, 448, and also 560. So the problem with this is we just got the points. Let's go and label those two. Alright, so there's our labels. And this one we would connect the points as well. Something like these. Alright, so that's a pretty good looking graph. What does the point 448 represent in context? So it represents him biking 4 hours and 48 miles. What does the point 00 represent? This one represents that. If he bikes 0 hours, he goes 0 miles. What is the unit rate? Annotate your table and graph to show the unit rate. So the unit rate, of course, was where the x is 1. So it would be right here. And in the graph, it would be this point right here, which represents 12 miles per hour. 12 miles for 1 hour. If John bikes for 10 hours at this rate, how far will he go? Well, it's 12 miles every 1 hour, so 12. And we could look at this in the table, right? That'd be 10 hours right there. If we extended this thing. So if he bikes for 10 hours, we would expect him to go 120 miles. So how do we get that? Well, we can make the unit rate 12 miles in 1 hour. And this should be equal to some number of miles in 10 hours. So what do? We multiply the 1 by 10 and the 12 by 10 to get 120 miles. 120 miles. Mary can bike 46 miles in 4 hours. Well, John shows that he can bike 60 miles. No, not 60, that's the wrong one. 48, very good. 48 miles in 4 hours, which is 2 miles faster. So John can bike more miles in the same amount of time. The table below shows the ratio of lemon juice to water for a new recipe. The graph shows the ratio of lemon juice to water used in the problem above. Plot the points in the table on the same coordinate plane using a different color. Alright, so the one that we did before is already graphed on there for us, which is extremely generous of them. But now we have this new one, which we need to graph as well. And the nice thing is that they gave us all the points already, so we just need to graph them. So they do have 0.00, and then we got 3, 2, which is right here. Then we got 6, 4, 9, 6, and that's all that'll fit on here. So next thing we should do is label each of these 0, 0, 3, 2, 6, 4, and 9, 6. And we can draw a line through it too. Alright, are the recipes the same? No, if they were the same, we'd have the same line. But in this case, they're different lines. Besides before, we can look at the unit rates as well, which are a little bit different. This one is 2 cups of water for 1 cup of lemon juice. And over here for 2 cups, it's, well, I think it's 1.3, but something like that. They're different. What is the unit rate for each recipe? So the line in black, that's 2 cups of water for 1 cup of lemon juice. And then we got the red line. So we'd want 1 cup of lemon juice on that. And it appears there would be 3/2 cups of water. So this person is using 5 cups of lemon juice. How many cups of water should she use for each recipe? So yeah, this first one here is 5 cups of lemon juice. So that would be 10 cups of water. And then the red line, that again is 5 cups of lemon juice. So we'd multiply that by 5 and we get 15/2 cups of water, H2O, which is about 7.5. It costs $2 for 5 oranges. So in the table we can see 5 oranges should cost $2. Complete the table and graph to represent the situation. So be it. So up in here, we can show this as 5 oranges for $2. Well, how much would this be for 1 orange? How many dollars? Well, we'll divide that by 5 and this by 5 as well. And yeah, that'd be 40 cents for 1 orange. So how much would it be for 2 oranges then? So 2 oranges now. Yeah, we just doubled this, right? So we'll double this as well. And you'd get 80 cents out of these. So we'll write that in. 80 cents. Now we'll be using the unit rate again though, 1 orange for 40 cents. And how much would this be for 3 oranges?
$1.20.
Yeah, very good. $1.20. Because we multiplied both these by 3, right? So we got $1.20. So let's just change this in. We'll go back, change this stuff. So what if we wanted 4 oranges? Well, then we'd multiply that by 4 and this by 4 as well. And it'd be $1.60. So we should be able to put these points on the graph once again. So we got a point at 1.40, 1 and 40 cents, which would be right here. 2 was 80, so 2 and 80 right here. 3 and 120. And then 4 and 160. And then 5 and $2. Bam. Now based on this we can see a pattern, which means we could continue this upwards. And also back to 0, 0. So that just helps us, but we should label these as well, just the ones we put in the table at least. Alright, so there's our labels for the ones that were from the table. Okay, so what does the unit rate show on the table and graph where we see the unit rate? Again, it's for 1 orange, which was this point right here. And again, we're looking for where the x is 1. So the rate was, we can write it like this if we want, 40 cents for 1 orange. So what if we buy 8 oranges? Well, we'd be looking at 8 in the table. And so 1 times 8 is 8. 0.4 times 8, $3.20. So it appears that this would be $3.20, which is shown at this point right here. 8 and $3.20. Owen paid $2.45 for 7 oranges. Did he pay more or less? Explain and use the graph to support. So we can see that the $7, 7 oranges. So our point up there for this one was 7 oranges for $2.80. Owen is paying less. So Owen paid less by, well, about 35 cents for the 7 oranges. Bam. There we go.